Okay, we have learned about a cost function, and we learned about a revenue function. There's one more function we're going to learn about, and it's called the profit function. The profit function is very easy to compute. The profit function gives the profit after producing and selling X items. Remember, there's a cost of producing them, and then there's revenue that comes in when you sell it. Hopefully the revenue will be greater than the cost of producing. So the formula for the profit is simply the revenue minus the cost. So you subtract. You take the revenue function and subtract the cost function, and that gives you the profit function, where R of X is the revenue that comes in from selling X items. X is the number of items. C of X is the cost of producing X items, and P of X is the profit after producing and selling X number of items. So number 10 is fairly straightforward. We're given the revenue function and the cost function. So find the profit function. I'll start way over here to the left. It's R of X minus C of X. And you may want to think of it as, you may want to write parentheses or brackets around the cost function. Just as a reminder, this cost function is a little bit complex. It's got a couple of terms in it. And there's a minus sign in front of it, so you need to distribute that minus sign all the way through the cost function. So for us, this will be R of X, which is 31.60x minus this right here. So I have to put it in parentheses, 11.50x plus 95. I left off the 0.00 on the $95. So remember, this is really going to be a minus 11.50x minus 95 when we do the distributing. And since I've kind of ran out of room, let's just do 3160 minus 1150x first, and that gives us 20.10. $20.10 x. And then we need to say minus 95. This is the profit function. So what that tells us, you can see the minus 95 because 95 was the fixed cost that came out of the cost function. So you got to subtract that from your profits each month. So, and then the $20.10 is simply the profit you make for selling each item. The cost, the revenue brought in minus the cost going out for each item. So the profit function is very simple. All right, our last example. It's kind of a four-parter here. It says that Acme Company sells its widgets for $15 each. So that would be like a little s, the revenue function, that little s, the sales price per item. And each widget costs $6.40 to produce. Acme's fixed cost is $142 per week. So we're dealing with a weekly revenue, cost, and eventually a profit function. So find the weekly cost function, revenue function, profit functions. So I'm going to try to squeeze those in up here. The easy one I always like to start with is the revenue function. R of X is equal to 15x. That's the money coming in. Each one sells for $15, so how much money is coming in? 15 times however many items that you're selling. Next one we'll do is the cost function, C of X. The cost function will be, well, how much does it cost to produce each item? I'm going to put 6.4 instead of $6.40 times X. $6.40 times the number of items that you're producing. And then we have to add in the fixed cost, plus 142. And the last function we have to do is the profit function, which we have to say it's 15x minus, in parentheses, this whole amount right here. So maybe I'll write that out. I'll write out 15x minus 6.4x plus 142. That's the cost function, and I put it in parentheses. So that makes p of x, if I simplify p of x, it gets 15x. Sorry, 15 minus 6.4x, so that'd be 8.6x. Minus 142. There, I kind of boxed in all of the functions. The revenue function, r of x, is 15x. The cost function is 6.4x plus 142. The profit function is 8.6x minus 142. All right, let's find, number 2 says find the break-even point. And it says to do it in 2 different ways. I think I might just do it in one way and let you do the other. And essentially, we're really doing exactly the same arithmetic either way. And you'll see how close they are. I'll set the cost function equal to the profit function. That's how I'm going to find the break-even point. So the cost function, we're on number 2. The cost function equals the revenue function. Well, that's an arrow. That means that cost function 6.4x plus 142 is equal to the revenue function, which was 15x. So we'll subtract 6.4x from both sides, and then we would have, let's see, that would be about 8.6x equals 142. Let me just go across this way. That means 8.6x equals 142. Kind of switch sides there. So I subtracted 6.4x from both sides, and that turned into 8.6x equals 142. So doing the division, that gives x is equal to 17. That's the break-even point. Sometimes called the break-even quantity, because when you produce and sell 17 items, your cost and the money and your outgoing cost and the incoming revenue are exactly the same, so you have zero profit. Okay, let's do number 3. I'm going to do it over here to the right. Not sure how much room I'll need, but here's the graph. It's going to look like this. And I'm not going to get really specific on this, but I want to get you to understand what the graph looks like when you graph the cost function, the revenue function, and even the profit function. Well, let's look at the cost function first. Here's the cost function. Well, this is just a linear function that has a y-intercept of 142, which I've drawn here, and a slope of 6.4. I'm just going to draw it like this. We'll say that's the cost function. The revenue function, what's the y-intercept of the revenue function? R of x equals 15x plus 0. So it's got the origin, 0, 0, as its y-intercept. Notice that the slope of the revenue function is 15, which is much greater than the slope of 6.4 in the cost function. So it's going to go up much steeper, and it's going to cross the cost function. And guess what the break-even point is? Well, it's exactly the x value right here. This, whatever number that is, would give us the break-even point. Let's see, and we determined what that was. So 17. And the break-even point, we usually think of it as a an XY pair, it would be 17 comma whatever this number is. I'm not going to plug it in. It would basically just be 15 times 17. That the Y portion would be kind of the break-even, not break-even quantity, but break-even dollars. That's the number of dollars going out in costs, which is equal to the number of dollars coming in as revenue. And then the profit function has a y-intercept of negative 142. So it would be down here. And it would just go up. Well, at this point, is where the profit is 0. So it crosses that point on the x-axis. So I didn't want to get too specific and label too many different ordered pairs in this graph, but just realize that the graph looks something like this. The revenue function, think of what would happen if the revenue function never crossed the cost function. If it were flatter, it would never cross it. That means your costs are always greater than your revenue. You'd go out of business in no time. Okay, last part of this is find the profit for x equals 5, quantity 25, quantity 105, quantity 220. So this will be part 4. Well, all we need to do is say what's C of 5 for the first one. P of 5, we're doing the profit. So all we need to do is plug a 5 into the profit function. The profit function we had written right over here, 8.6 times 5 minus 142. Minus 142. Sorry about that, it's a little messy. Let me rewrite that. Minus 142. And that profit would end up being a negative number. So if this company produces and sells only 5 items, the profit is negative. You're going to lose $99. P of 10, if you plug it in, you get 8.6 times 10 minus 142, and that would be negative $56. The profit on producing and selling 105 items, if you plug it in, you get 105. You get 8.6 times 105 minus 42, you get $761. That's good, you get some profit. And then finally, the profit on 220 items turns out to be 8.6 times 220 minus 142 gives you 1750. And I probably should have put dollar signs on all of those, but I'll leave it that way. So that does go to verify that our break-even point was 17. In this case, if we produced 17 items, the profit would be 0. When you produce fewer than 17, say 5 or 10, you lose money, you have a negative profit. If the numbers are greater than 17, like in these two examples, we get $761 and $1,750, and that's profit.